Physics students, good afternoon. Mr. Fugit here. In our video today, we're going to be looking at a few of the problems from your review on test number 1, which covers over units 0 and 1, which are unit 0 being density and unit 1 being what we covered with vectors. Specifically here, we're going to be looking at problems number 15 and 16, which cover over unit 0 on density. So, we're going to start by looking at problem number 15. As a reminder, copies of your review, as well as the key for the review, are located on Canvas in the Unit 0 and Unit 1 pages. So, problem number 15 says this. A friend of mine is starting a business to make ball bearings. So here, we already know we're dealing with objects that are modeled as balls, which means you can treat them as geometrically a sphere. It's an important piece of information. He has bought little nuggets of steel and wants to turn them into ball bearings. He wants to make ball bearings with a diameter of 2.5 centimeters. And what will the mass of one bearing be so he can melt the right amount to make each one? Okay, so let's go ahead and write down the other things we know. We know we're dealing with steel here. So that should tell us our density. You can look at my chart just in case I have forgotten. It should be in the 7-ish range. So we'll go, according to the chart, 7.8 grams per cubic centimeter. And he wants to make spherical with a diameter of 2.5. Okay, so we have a diameter of 2.5 centimeters. And again, when we're given a diameter, that should raise the alarm in our minds, we are probably going to need the radius here. So we'll go ahead and cut that diameter in half. Radius is diameter over 2. This will be 1.25 centimeters. Yes. Okay? Okay, the question says, what will the mass of one bearing be so he can melt the right amount to make each one? So we're here looking for a mass, similar to what we did in problem number 14. Okay. So we're dealing with volumes, densities, and dimensions of our sphere here. So we're probably going to need to use our density equation. Looks like this. Rho density is mass divided by volume. And as we did previously, if we want to get mass by itself, we have to get rid of the volume variable in our denominator. So multiply by V, multiply by V. So volume over volume. Okay, that will cancel out. And we'll now have an expression for mass that looks like this. Mass is equal to our volume multiplied by the density. So in order to get to the mass, we need our volume and we need our density. Now looking back at what we're given, we already know the density value, right? We're told this is steel, so we can assume a density of 7.8. We don't know, however, the volume. So that might need to be a little side step we take in order to get to our answer. So let's go there first. We're going to do this in green. The volume here, we have a sphere, is equal to 4/3 pi r cubed. Okay? That is the defined equation for the volume of a sphere. So we'll plug in the things that we know. Well, really, the only thing we need to plug in here is radius, which is half of our diameter. So 2.5 over 2 is 1.25 centimeters cubed. Remember, our equation does not have diameter in it, it has radius. Okay, so now we'll plug these values in. Volume is 4/3 pi times our radius, 1.25 centimeters cubed. We should get a value of approximately 8.18. So our volume, 8.18 cubic centimeters. So now we know our volume value. Now we just need to plug into our equation up here to find our final answer, which would be mass. So our mass is the product of volume, 8.18 cubic centimeters, multiplied by density. I'm going to erase this because it's a little bit in the way. Sorry there. Density for steel, 7.8 grams per cubic centimeter. And really here, we can see the units will lead us to confirming our answer, centimeters cubed over centimeters cubed. Those cancel out, we're left with units of grams. So now we have 8.18 multiplied by 7.8, and we get a mass value of approximately 63.8 grams. So here, a very similar approach to what we did in problem 14, but now we have to go through a side step finding the volume in order to get to our desired answer, which was the mass. So again, as we've talked about, there are a lot of applications of dealing with density, volumes of different shapes, their dimensions, things of that nature. But this is a good application for something you might see on the exam. Okay, now our last problem related to density on the review is number 16, and it says this. You have been put in charge of designing a conveyor system for packages at the post office. Part of the system will rely on nylon rollers. Okay, so that's a descriptive term. We're dealing with nylon. Tells us what material we have, so I'll double check my chart. Nylon has a density of 1.2 grams per cubic centimeter. Okay, so we know that information. They are cylinders that will spin to let packages roll along them. The cylinders will have a height of 25 centimeters and cannot have a mass more than 600 grams each. So the mass that we can design for, like the maximum value we could have here, would be 600 grams. What is the greatest diameter the rollers can have to meet the mass and height requirements? Really all that means is, if we're designing for this height and for this mass, what would the radius and the, what would the diameter be? We might need to use radius to get there, but what is the greatest diameter we can have? Okay, so we have quite a few things here. We know the material that we'll be making our cylinders out of. We know the height of our cylinder. We know the mass. We are looking for the diameter. Now, diameter does not show up in any of our equations for volume. But here's what we do know. Diameter is 2 times our radius. So if we know the radius, we can get the diameter directly. Radius shows up in our volume equation, and here we're dealing with the cylinder. So our volume equation should look like this. Pi multiplied by our radius squared multiplied by our height. So if we can find our volume, we can find the radius, and if we can find the radius, we can get to the diameter. So there are a few steps that we need to get through here, which you're oftentimes going to see in a problem that I ask you. There isn't going to be just one thing we have to do. There are a few steps that we have to build onto. So let's first see if we can find our volume. Well, we know that volume shows up in our equation for density. So density rho is mass divided by volume. Now I want to get volume by itself here. So I would multiply volume into the numerator on both sides of my equation. So volume times volume, those things will cancel out. Now we'll have an equation that looks like this. Volume multiplied by density equals mass. And now I could, to get volume by itself, divide by density, rho. So rho over rho cancels out. And now we have an expression that looks like this. Volume is mass divided by density. So I think we know the mass here. We also know the density because we know the material. So let's plug the values in that we know. Our volume is equal to mass, which was 600 grams, I believe. Excuse me, losing my voice here. 600 grams, yep. Divided by our density, which this is nylon, so it should be a pretty light material, relatively. So 600 divided by 1.2, we get a volume of 500 cubic centimeters. Now remember, that is not the answer we're looking for. It's just a way to get to our answer. So now we know our volume, we can plug into our equation for volume. And we're going to come down here, and to do that, but we know volume, we can use that to find radius, and then eventually use that to find diameter. So we're going to keep working. Our volume of a cylinder is equal to pi multiplied by the radius squared multiplied by the height. So I'm going to plug in the things that I know. There we go. Excuse me. So our volume here was 500 cubic centimeters. And that's equal to pi, which we're not going to plug a value in for. It's a kind of a mathematical number that we can just use in our calculator. Multiplied by r squared, multiplied by 25. And we just plugged in what the height value was that we were given in the problem. Now, if we want to get r squared by itself, there are a few things that we have to do. One, I need to divide by pi. I also need to divide by 25, right? So I can divide by 25 pi. And that's going to mirror on the other side of my equation. Divide by 25 pi. So I'll take 500 divided by 25 pi. So 25 and pi, those values will cancel out. And now I'll be left with, well, r squared is equal to 500 divided by 25 pi, which gives me about 62.8. And then lastly here, we'll take a square root to get our radius by itself. So square root of our value. I made a mistake. Let's see. 600, nylon, diameter. Let's see. Let's see if I can track what I did here. Maybe I'll just have to toss this. Nylon. Volume. Oh. There we go. 500 over 25 pi. Here's my issue. 500 over 25 pi is actually not 62.3. It's actually 6.36. There we go. That was my problem. And then you seem a little bit off, so we'll take a square root because we have 6.36. That seems much more appropriate. There we go. So now we have a radius value, good, of about 2.52 centimeters. And remember, diameter is 2 times our radius, which will give us about 5 points, let's see, a little over 5, about 5.04. So again, very easy for me to make mistakes as well as I'm working through some of these problems. Okay? And again, that was an example of a calculator error. I didn't plug something in correctly. So again, it reinforces the idea of, hey, it's not just enough to know how to set these up conceptually, how we plug them in is important. And hopefully that gives us some good direction on problems 15 and 16 on your review for test number 1. Good luck.